Gentlemen, I'm really excited for this next conversation. So TED has opened up the guidelines. It used to be all TED Talks needed to be less than 18 minutes, and they needed to be talks. And now they're welcoming conversation. And I thought, who better to have a conversation with than Paul, a very distinguished computer scientist and innovator and leader. Was at Carnegie Mellon for a while and was heavily recruited in a worldwide search to come join MIT. And something that's stuck with me, I don't know how true it is, but if you eat a strawberry, when you eat the strawberry, it can tantalize like 255 taste buds on your tongue. But if you eat a Jolly Rancher that is strawberry, it's tantalizing 5 taste buds. And so if a kid grows up having more Jolly Ranchers than strawberries, do they think the strawberry is really the Jolly Rancher taste? And, our society's been seduced by images. Facebook and other social media has made sure that I think millennials and Gen Z take so many selfies to the point where they're like the center of the universe. And that's because we've been seduced by the visual. But we have all these other senses. And I remember reading Slaughterhouse-Five when I was growing up, the Tralfamadorians. They saw things in multiple dimensions. They could see a pencil, its beginning, its current, its future. I remember Madeleine L'Engle. There were characters that had other senses that we can't even imagine that she wrote in her fantasy stories. Well, sitting next to me is one of the leaders in the world on what is capable from our senses and how AI can complement that and help us be a better species, be a better community, and innovate in some extraordinary ways. Now, I don't know if I did justice to Paul's research, but just to start out, this is no ordinary individual. Ladies and gentlemen, Paul, can you maybe introduce yourself as you might want the world to know you briefly, and then maybe talk about smell and AI. That'll be my first question to you. But first, introduce yourself.
Yes, absolutely. Thanks, John. Thanks for having me. So I'm really excited about expanding the capabilities of AI systems. And I think AI systems today are still very, very far away from humans, right? People talk about AGI all the time in Silicon Valley. They only perceive a very, very narrow slice of the world, right? Humans, like we see, we hear, we touch, we smell and taste. And it is this whole congregation, accumulation of all senses that allows us to really perceive and interact with the world. But AI is just so far away from perceiving all of these senses, right? We have AI that can understand a text that we type on a computer, that we speak to it. It's very purely natural language. And we're starting to see a bit more advancements in AI that can see images, but these are still very much natural images. And very, very far away from AI that can hear, that can touch, that can smell and taste like people can. So really excited to be here, and my group is called Multisensory Intelligence. We're trying to build AI for all senses so that they can really perceive and interact with the world like people can. As John mentioned, one of the projects I'm most excited about is this potential for AI to smell like people can. Smell is just so important, right? It's what affects our perception of what is good, what is bad. It brings connection. We send our friends and families the food that we're eating. Imagine a future where we could send not just the photos of the food that we're eating, but also send the smells that we're eating together with our friends and families. Smell is the only modality that can allow us to see the past. Using smell, you can detect what food and beverages were here 30 seconds or a couple of minutes ago. You can detect how many people were in this room. And that's the only modality. Vision can't do it, language can't do it, sound can't do it. Smell is the only modality that lets us see the past. And that's why I'm so excited about this future about where AI can perceive not just through language, but really all the senses like people can.
So, Paul, can you talk a little bit about your academic journey? What were the building blocks for you to kind of take a risk and go into the space that not a lot of people are in? Did you come up with a PhD in smell?
No, not smell. I think that's a very new frontier they're trying to tackle. But I started my PhD in 2018. If folks recall, that was the era of when deep learning had proliferated computer vision, and we had started to see early signs of language models, right? And being indecisive, I didn't know whether to work on natural language and large language models or computer vision or speech processing. And there was a very new area of research on understanding human communication. And as we all know, human communication is multifaceted, right? We speak through verbal words, and we tie that together with facial expressions, with tone of voice. And I thought that would be a great way to kind of combine natural language processing and visual processing of human faces and speech processing of tone and gesture and come up with better methods to really understand a person, their behaviors, and when they're communicating these behaviors. So I was really lucky, we started working on some of these multimodal models early on. And then when large language models became developed, all of industry started pivoting towards this vision language models, these multimodal models, and we're able to carry on some of this momentum even till today.
So let me ask you this. Can you walk through the different senses? Which do you think there is unique possibilities with AI that people don't realize? Maybe kind of rate them, which have the most potential. And then can you see technology helping to create senses that we don't even realize we could have? I think of being able to walk around and see Wi-Fi. We can't see Wi-Fi with our eyes, or being able to see where heat is escaping spaces. Is that an extension of vision, or is that like a new sense? And with technology, are there other things that we could just like put right into our brain? And I remember, I think at MGH, someone was telling me a story how a metal pipe went through someone's brain, and they were able to learn a lot about how the brain worked. My guess is some of what you're doing is also thinking about how as a species we can work with technology, and especially how our brain can interact with technology. And my guess is, that's a space that your group is going to double down on, and I'd like to know a little bit about that. But to start with, maybe list the senses, rank them, and can we have other senses that we didn't know we could have or want?
Yeah, absolutely. So, we've seen great progress in language, of course. Vision and audio are probably the next senses that we can really capture using AI. And primarily, we have lots of language, vision, and audio data on the internet. I think the next sense that we're going to tackle is the sense of touch, right? And I like to give this example. Roboticists might have heard this example, but this idea of the Moravec's paradox. It is this paradox that says what is really easy for humans is really hard for AI. And what is really hard for humans is conversely very easy for AI. And the example they love to give is, as a human, it's super trivial to pick up an object. To shake somebody's hand, to grip a microphone. You don't even think about it. It's so intuitive, right? This sense of touch. But at the same time, we don't have robots that can grasp all types of microphones, that can pick up all types of objects, that can shake all people's hands with the right force and gestures. And why is that, right? The sense of touch is just so naturally built in that we can't even describe, because it's so intuitive, we can't even describe in language what touch and force means, which means it's very hard for AI systems to learn that. At the same time, what we think is really difficult, like passing SATs or bar exams or achieving gold at international math Olympiads, we spend so much time trying to figure out these difficult problems that we have so much knowledge on the internet about it. And that's why we see AI crushing SATs, law exams, IMO, mathematical Olympiads. But we're very close. I think touch is the next sense that we're very close to capturing. There's lots of progress in trying to tackle this paradox and building sensors that, allow you to digitize how much force you're putting per square inch across spatial resolutions as you're gripping and, manipulating different objects. And that's going to be the next one to fall. And of course, I think smell and taste are the ones that are, of course, even further away. And we need new sensors, we need lots of data, and we need new AI modeling paradigms to really enable these senses in AI systems.
So in terms of touch, two things come to mind. One, could you make someone think they're touching something when they're not? Is your research going down that path? And then for people who may be have limited mobility, maybe lost some sense, for fire burns or born that way, can you give them that touch? I don't know if that's the same thing, but is your group looking into either of those options?
Yeah, absolutely. I think this goes back to the previous point you made about this case study where a person had a metal rod that affected them, that went through their head, and they lost some senses and they gained some other senses. And us humans, we're really good at this. We have this, this concept of cross-modal plasticity, right? If your brain loses the ability to sense in one of them, they recover and you become much better at another sense, right? But AI models don't have this, right? AI models, if you're equipping a language model, if the language model can't read language, it can't do anything else. It can't suddenly transform to a model that sees images better or to hear audio better. So that's a really cool frontier for AI, I believe. And again, back to your question, we're doing a lot of work in tactile sensing, so capturing the sense of touch, how people move and manipulate different objects. The corresponding version is haptics, right? We're also building these gloves. These are called haptic intuition gloves, interaction gloves that can essentially allow people to feel something on their hands, right? So a person who might lose their sense of touch or lose sensitivity in their hands, with strong enough haptics to actually be able to feel something that they couldn't actually feel before.
So there's 6 senses?
I would say there's, classically in biology, there's 5. You see, hear, touch, smell, and taste. By extension, people think other senses, intuition is often a sense.
Yeah, spidey sense.
Spidey sense, intuition, yes.
Yeah. So are there an 8, 9, 10 that you could create? And people talk about artificial intelligence, but some people say the A could be augmented intelligence, and that if you could create these other senses that hasn't evolved to date, we would have a very different kind of experience. Is your group thinking about 8, 9, and 10?
Yeah, absolutely. I would say, memory is a huge sense, right? The ability to remember long things way into the past, to augment current decisions with long-term memory beyond short-term memory, is especially important, right? And I see AI as being a very powerful enabler of that. AI technically has unbounded memory. If you have unbounded compute, you can help you remember things, 1 year ago that you met this person, and here are some common talking points. So memory is a big one. Being able to do higher level reasoning is another big one, right? If you look at all this work in AI for health, right? We have these physiological sensors tracking our sleep, tracking our diet, tracking our breathing.
Yeah.
All of this is data that we can't process by ourselves.
Quantified health, yeah.
AI can help us, right? AI can externalize and better augment our decisions around our health and well-being. So again, I see, there's lots of senses that we got to build into AI systems, and at the same time, a lot of senses that AI can provide that we don't have.
So you haven't mentioned BCI for people who may not know, brain-computer interface. Is your group do research into that? Are you at the forefront of that, or are you letting other people think about that?
Yeah, I think BCIs is something, BCIs and AI will integrate probably in this time span of 10 or 20 years.
Yeah.
Right? In the next 10 years.
But is your group looking into that?
In the next 10 years, we're focusing on AI.
Yeah.
Right? I think in 10 or 20 year time span, we're going to have AI that is really powerful enough and miniature enough that you can implant into people's brains. And of course, you got to tackle all these challenges about robustness, about privacy, about making decisions that actually augment people instead of overriding people. And that's like a 10 or 20 year horizon.
Yeah. So let me ask you this. The name of your group again is?
Multisensory Intelligence.
So you need to recruit a talented range of people, because you can't have all people are expert at smell. You wouldn't be able to do all the things you want to do. For people who are listening, if they wanted to join your group or thought they'd have something to contribute, what are you looking for as you think about the important research you're doing in the years to come?
I would say, we're looking for people who expand the horizons in our group, right? We're trying to improve and expand the convex hull of capabilities and bring about new insights, just to, find ways of bringing together different disciplines, right? AI for smell, you wouldn't be able to tackle this without people who are, of course, passionate and have experience in AI, but people who know the biology, who know the chemistry of how people smell, who have experience in neuroscience, who are able to fabricate and build really cool technologies that go beyond the computer. And that's why, I love being at MIT and I love being in the Media Lab, because you have this connection of multiple disciplines that enable new opportunities in research.
Great. What's your, just in closing, what's your favorite smell? What's your favorite taste? What's your favorite haptic experience as you lead your group? Your team probably knows that, and you probably double down on some of those, or it's part of the theme of the group.
Yeah, we're trying to build this multisensory experience. If y'all come by next April at the Media Labs Members Week, we're trying to build this exhibition where you can type in a prompt of your favorite memory, right? Walking down the streets of Paris in the early morning with this misty coffee and baguettes. You type in a prompt of your favorite memory, and you'll go into this room where you could first, of course, see the imagery of that, and that's pretty much easy. But you could also be able to smell what that smells like. You'll be able to feel using haptics gloves, the sensation, picking up a croissant, drinking hot coffee, and that will really round up the multisensory experience. And they'll be personalized. Any favorite memory of yours, you'll be able to try it out in this new system.
Great. Well, you guys, I asked Paul to send me some questions, and he did, but I don't have cell signal, so I couldn't read any of the questions. So I was just winging this. This won't be in the talk, but I apologize that I didn't ask the questions that he sent me. But who found that a little bit interesting? And the reason I did this interview was I want Paul to do a linear talk in the semesters to come, and I want to send out this interview and say, come hear Paul's talk. And I just think he's on to some cutting edge research that's so important. Paul, thank you for today.
Thanks for having me.